Welcome, everyone. Thank you for joining our webinar using unsupervised machine learning to verify production deployments. My name is Greg Howard, and I run growth marketing at Harness, the industry's first continuous delivery as a service solution. A few points before we get started. If you have any questions during the presentation, feel free to type them into the question box in your control panel. We will answer as many questions as we can when we are done. And if we don't get to your question, we'll be sure to reach out after the webinar. Located in the control panel, you'll also see some handouts and white papers that you can download, including a Harness data sheet, a customer case study, and a white paper detailing the primary features within our continuous delivery platform. And keep in mind that this webinar will be recorded, and we will be sure to send all participants a copy of the recording within the next 48 hours. That's it for me. I'm now very pleased to introduce our presenter, which is Steve Burton, the Harness resident CI/CD expert and DevOps geek. Prior to Harness, Steve did awesome tech stuff at companies like AppDynamics, MoveSoft, and Glassdoor. When he's not playing around with technology, he's normally watching Formula One or researching cars on the internet. Steve, thanks for joining us today.
Thanks, Greg. Welcome, everyone. As you can see, I put every conceivable buzzword in the title, so much so it actually confused my co-presenter who couldn't pronounce it correctly. So well done, Greg. For the next kind of 30, 40 minutes, what I'm going to do is I'm going to talk high level about the use cases we're solving in CI/CD, and then I'll drill into the low-level details of how we actually use unsupervised machine learning. So I'll actually step through the algorithms, I'll show you the results, I'll show you how we improve accuracy, and kind of give you a sense of how you can use machine learning in kind of real life use cases there. So a little bit about me. My background is actually development. So I was actually developing Java a long time ago, Java 1.3, where you had like crazy things like EJBs and struts and WebLogic and WebSphere, and the world was all Oracle. How times have changed. Most recently, I was kind of like tech evangelist at AppDynamics. So my background is a lot to do with things like bytecode instrumentation, distributed transaction tracing, kind of understanding the core mechanics of a JVM or a CLR or runtime environments. And then most recently at Harness, where we're obviously doing continuous delivery. Fun fact, I like to dress up in character outfits. So this is kind of one of the characters I dressed up as at AppDynamics. You can see here's me with the San Francisco Police Department at Java 1. Who knows, there may be another superhero costume on the way. Anyway, good place to start. So I started my career as a developer. So back in 2003, I worked on this huge project for the UK government. It was at the time where the government was like, hey, this thing called the internet sounds good. We should be part of that. So they basically mandated that every department in the government needed to be online. And so I worked on a Java project with about 100, 120 developers, and we built a content management system for the UK government. And it took us 2.5 years to build. It was probably the biggest waterfall project you can imagine. And it went live. And basically, it went live and it looked like this. And we were like, awesome, the site's up. Everyone's good. Let's go to the bar and get drunk. And so we did that. And then literally a few hours later, the site crashed. So after 2.5 years and God knows how many man hours, the actual government website went down. Now, this might be okay if the company you built a content management system for was like a small company or a mid-sized company, but when it's the UK government, it's kind of important. And what happened was we basically were written the rights and said, look, if you guys can't fix this or tell us what's wrong, we're going to roll back the vignette. And basically threatened us. And so our best engineers spent, I think it was like 6 or 7 weeks debugging to try and figure out what the root cause was. And in that process, we decompiled WebLogic source code and basically like looked into every rock. And what the issue was the search engine. So when a search engine, as you see here on the homepage, when it contained a certain word, it would cause the search engines to go into an infinite loop. And because the search engines were embedded in WebLogic, it basically brought down the entire application. And that word was Hoon, H-O-N-N. And the reason for it was the defense minister in the UK was called Jeff Hoon. So people were searching for him. And basically the reason I'm saying this is a lot of customers today feel like if the system's up and running and it's available, everything's good. Like the measure of a deployment is often, did the site stay up? Yes or no? And what I'm trying to get at here is it's like that might come across as correct, but there's a lot of things that typically go wrong with applications that are hidden, and first appearances can often be deceptive. And so as I kind of mentioned, like the world's changed. Like I kind of had it easy when I was a developer. Like I had literally 3 tiers. If you kind of compare that today with microservices and serverless and Lambda and all the distributed kind of NoSQL environments, like you've got a lot of technology and potentially hundreds of thousands of things to manage. And with all of those components, you have metrics, you have log files, you have telemetry, you have data sets. And so like what we're managing today is really 100, maybe 1,000 times bigger or more complex than what we were managing 10, 15 years ago. And so going from agile, where you talk about having bi-weekly scrums or deployments, to continuous delivery where you're deploying every hour, like that's a complete fundamental shift to how you manage not only deployments, but the impact of those deployments. Like I've always been kind of curious as to know, like, what's the real reason you do DevOps? Oh, well, it's because I want to cut time to market. All right, why do you want to do that? Because the business basically wants to make money. Okay, so you're making all these changes. And so if I asked you what the impact of all these changes you made was on the business, could you tell me the answer? And 9 times out of 10, the answer is I can't, because developers never really get any operational feedback from how applications are running in production, right? Same with me. When I was a developer, I used to work on certain packages or certain features. It would then go to an operations team who would do the deployment, and they would take care of it. Like I never got any feedback as to whether anyone was using the stuff that I built, whether it ran fast, whether it generated errors in the log files. Like that was completely hidden. And I think in today's world, where what we're noticing is customers are shifting left. So developers are almost being empowered to automate the deployments and get operational visibility. That's kind of super important. And so if I'm going to define like CI/CD and what it looks like today, what we see at Harness is continuous integration is about taking code to artifact. And this is largely a solved problem, right? Customers have been using Jenkins and Bamboo and a lot of the tools you see here for well over 5 or 6 years. And so this process is fairly mature. But the process of taking artifacts into production, into customers, is still relatively a manual effort. And what we notice is most customers are trying to build on top of their continuous integration tool sets. And so everything you see on the right is the components and the jigsaw of continuous delivery. And so things like canary deployments, blue, green, how you do health checks, how you roll back, how you manage secrets, and a lot of the reporting, the environment variables, all of that's kind of like stitched together with bubblegum and super glue and kind of wrapped around like things like a Jenkins job. And so at Harness, what we're trying to do is we're trying to simplify everything on the right-hand side. And so what we see with customers is there's 3 maturity levels they're at. Number 1 is where IT operations has dedicated teams to do deployments. So you might have a release team, a deployment team, and typically the velocity we see is like once a month, maybe once every 2 weeks. And so the challenge here is that IT ops becomes a bottleneck. And so what a lot of companies do is say, I need a DevOps team. So I'm going to go and hire some DevOps engineers. They're going to build the deployment pipelines. They're going to babysit the deployments. And you can probably get deployments down to weekly, right? And that's traditionally a custom build. You'll see lots of job postings for automation engineers and platform infrastructure engineers. It's not unusual for DevOps to build continuous delivery. But ultimately, where we get a few customers, and certainly what we're looking to provide at Harness, is where continuous delivery is a service, where developers can build their own pipelines, they can do the deployments, but they can do it in a controlled way. So typically what we're trying to enable is where the DevOps kind of govern the process, but they empower the developers to automate the building of the pipelines, the deployment, and how they verify, and even in some respects, how they roll back production deployments. And so I'd say 80% of the market right now is in maturity level 1. I'd say probably West Coast and East Coast of the US and parts of Europe is probably at stage 2. And less than 1% of customers are actually doing real continuous delivery as a service where developers are fully empowered to kind of do the processes. And so it'll come as no surprise that CD is about automating everything. Love that word, just automate everything. Everything you see in the dev environments, we've been doing for years. So static code analysis, integration tests. You can then talk about promoting code to QA and then automating all of the kind of regression tests, the functional tests, the performance testing, things like that. The coolest thing to do today is to actually test in production. So you'll hear canary deployments, canary phases, kind of rolling out to a kind of controlled set of users, testing to see if the application behaves well, in addition to all of the tests you kind of see there. And so being able to automate all of this process, you effectively empower the pipeline to dictate whether the code is ready to go to a customer versus a human. And so that's the ultimate goal is to remove humans from this process. So when you commit and you check code in, the code passes through these different stages in the pipeline, and it's really down to the pipeline itself to say, is it ready for the customer, yes or no? And so what we do at Harness is we help customers build those pipelines. And so if you've got a dev, a QA environment in production, you've got all the different technologies and tools, you see that. What customers are doing today is they're building it themselves. They're building the wiring, they're building the plumbing, and they're basically building a continuous delivery platform. And so all we're trying to do at Harness is basically tip the balance and kind of let the tool do most of the work. And so whether you want to script it as YAML, you can do that. Whether you want to use a wizard or a UI, you can also do that. So this is the first thing Harness does. Specifically for this webinar, what I want to talk about is our continuous verification. And this is where we use an unsupervised machine learning. So once we do the deployment, what we're actually going to do is connect to all your monitoring tools. So if you've got APM tools, if you've got log tools, if you've even got custom time series metrics, we're going to go to the tools that are watching your production application. And we're going to use machine learning to build a model of what we see in each of those tools. And then we're going to use algorithms to understand what the business impact is of the deployment. So if need be, we can roll back. And so what we're trying to allow developers to do is to use machine learning to verify almost immediately whether their production deployments were successful or whether they weren't. And that's kind of like the high level, kind of like why are we using machine learning in the continuous delivery process. And so I want to start with a real example of a customer. This is a public case study. You can go to our blog and check it out. This is Bill.com, so $1 billion kind of e-commerce website similar to Home Depot. And you can see they did a production deployment and one of their web services basically failed. You can see phase 1 actually failed, and you can see there's a rollback. And if we jump into what that pipeline looks like, you can see it right here. So this pipeline has 7 stages. You've got the development environments and the test environments on the left. You've got some sandboxes, you've got a staging environment, and then you've got a manual approval before the code is deployed into production. And you can see on the right-hand side that the production step is failed. And so what we're going to do is we're going to drill into that production step, and we can see the individual steps that happened during that deployment. So you can see in phase 1 that the deployment itself was actually successful. Everything was green. So in terms of copying the artifacts to the servers and updating the configuration, everything was good. We then marked the deployment in New Relic. And then what we did is we connected to New Relic and Sumo logic. And that's where our machine learning goes and takes a look at the performance metrics in New Relic. It goes and looks at the application logs in Sumo logic. And it tries to understand for the artifact we just deployed and the compute infrastructure, what happened to the application from a performance and from a regression perspective. And so you can see Sumo logic here is red. And so if we drill into that, you can see here, here's the screenshot from Harness showing the exceptions for the application during the time of the deployment. You can also see the email at the top that the customer kindly sent us that said, hey, we just did a deployment in production, and literally immediately we picked it up. And what we see here is the red dots represent new errors and exceptions that were introduced as part of the deployment. whereas the gray dots represent baseline events, which we observe in every deployment. So this is just a simple example of how you can use machine learning to pretty much instantly know what changed or what was introduced into the application. And so you see these 4 dots here. These turned out to be NullPointer exceptions. And it happened to be in one of their important services, which is kind of blurred out. You can see that. But bottom line, like, this was impacting their online e-commerce business. And what's cool about this is not only do we flag and tell the developers what the exceptions are that were introduced, but we give them a safety net. So literally seconds after we identified the anomalies, the application automatically rolled back. And so you can see the start time and the end time of the rollback. That's 32 seconds. And so what's kind of key about this is rolling back in 30 seconds it is extremely fast. The developers know why the rollback occurred because they can go in and they can see the exceptions that were introduced, or they can see any deviation. And this is really how we use the machine learning. We're telling the customer, this is the business impact of a deployment. Do you want to automatically roll back? Yes or no? And the customer has that discretion. Rollback can be fully automatic, or you can have manual intervention. And so, as I kind of talked about, deployment verification today is all of these things, right? And so you go and speak to someone and say, hey, did that deployment go well? You're probably going to get one of these responses. And it leads us into a false sense of security because we want to believe the application's working because we don't want to spend time fixing it or debugging or troubleshooting. But no one really knows or can quantify what the business impact was of that deployment. And so if I go back to that DevOps analogy, if we're making all these changes to try and make the business better, and yet you can't tell me whether you made the business better or not, those changes are kind of like, what's the point? You're kind of doing things and not having anything to show for it at the end of the day. And so that's what we're trying to help customers understand. And so as I kind of walk through the example use case, build before harnessing the machine learning, what they did, it was 3 production deployments a week. And in every one of those production deployments, they had 6 team leads spending an hour manually looking at New Relic and manually looking at Sumo Logic. And so they were burning 360 minutes per deployment just to verify it and make sure everything was good in a deployment. And a rollback at minimum was 30 minutes, and that was 2 team leads. And so the rollback process itself was manual as well. It was a bunch of scripts that had to be run in certain orders to get the old artifacts to kind of roll back the configuration. And this is very similar to what we see in customers. iHerb's another example, again, multi-million-dollar business. They do 20 production deployments a day. And they're burning about 120 hours babysitting deployments across, they have lots of dev teams. And so the numbers start to add up. And so typically when you think of continuous delivery, you're thinking, hey, it's just about automating the deployment. It kind of actually isn't, because if those deployments go south, you've almost got to figure out what's broken and how you roll back. And that sniff test or that verification or that health check is often your kind of measure of whether the deployment was successful or not. Here's another example, Saas Vendor. This was their current CI/CD process. So you can see on the build and deploy, they've got Jenkins jobs with a few CF templates. Once they did a nightly build, they then had 4 different processes. They would look at information in AppDynamics, Splunk, CloudWatch, and they actually had custom metrics from the application itself. And basically, you had different people looking at different aspects of the build to try and validate whether the build was ready for customers or not. And so a nightly build would literally take 6 or 7 people a few days to basically say, yep, it's ready to go. And so, like, if you kind of think about this manual process, we can use machine learning to automate that entire verification, okay? And that's a huge win, right? You can validate a build in less than an hour versus 2 days. And that's really what's going to help you kind of get to continuous delivery. So bottom line is, you probably feel like this if you've ever tried to validate and test a build. It's not much fun. It's kind of boring. I've kind of been there. And so we want to basically get rid of that feeling of feeling like an English bulldog that's kind of fat and ugly and kind of just sat on the floor waiting for food. That's a joke. English joke because it's an English bulldog. Right. So continuous verification for deployments. What are we trying to do at Harness? Two key things. We're trying to understand functional regressions in an application once we've done a deployment, and we're trying to understand performance regressions. And so two simple things is, did the performance of my app improve or get worse? And did I actually introduce any errors or exceptions or quality issues to the application with the deployment? And so that's kind of at a high level what continuous verification is. It allows developers to use machine learning to figure these things out incredibly quickly. I will preface and say machine learning is not a silver bullet. Out of the box, it's about 65% accurate. You can increase the accuracy over time by giving it supervision. So giving it pointers, giving it tips, kind of reinforcing the results that the machine learning is giving you. What I will say is it's much more better and accurate than humans. So being humans, and especially engineers, we like to think we're right all of the time. It's actually incredibly difficult for even the best DevOps engineers to analyze billions of metrics and to analyze millions of log file entries. Systems are so complex, even the best engineers struggle. And I know that because I've debugged production environments. I've seen big outages and how difficult it can be. And it's part of the reason why rollback and troubleshooting takes hours and if not days. So I'm going to talk a little bit about control and test data. For Harness, our control data is previous deployments and previous canary phases. So when we look and compare models of deployments, we're really looking at the last deployment or the last canary phase specific to the artifact we're deploying and the compute infrastructure that it's deployed on. And the test data is going to be the new deployment and the new canary phases. So just to kind of level set with you on that. And so let's start with like identifying anomalies in log files, because everyone loves a good grep. If I was to say, right, here's a log file that's a terabyte, go and identify the anomalies that were related to the last deployment. Who do you think's faster, machine learning or humans? What do you think, Greg?
I'm going to have to say the machine learning, Steve.
I tend to agree with you. Yeah. I know this because in one of my previous jobs, I was so boring. I went and analyzed the billing events from application logs. So we had a product. It was a SaaS product. There was 1,000 applications, and I could go to analyze all of the log events from that. And what I noticed was that the average Java application threw 9 million errors a month. It generates about almost 3 terabytes of storage a month, which is crazy. And the average application contains about 50 unique errors. And what was super scary was that 97% of log files were actually just 10 errors. And as you might expect, NullPointer, everyone's favorite exception, was actually the most common. And so bottom line is if you fix 10 of those errors in your app, you probably reduce the log files by 97%. And so there's a lot of noise in log files, yet it's the first place we go. And even with log tools like Splunk or Sumo Logic or Elastic, it's down to the users and the operators to search, right? You got to know what you need to look for. And so even then, you might do a search and you might get 5,000 results back. It's not always obvious which exceptions are related to the deployment you've just done. And so if we define what machine learning is, unsupervised is really where the algorithms identify the meaning and context from the data by themselves. There's no human input. You can give it any data set and it's going to understand relationships. It's going to try and understand the meaning of what it's parsing. And so things like natural language processing, where you can break up text, you can tokenize it into attributes, you can look at values, you can look at the sequence of those tokens. That's really kind of a form of unsupervised machine learning. And again, neural networks where you can feed it information and over time it can learn what it's observing and use that to better refine for future. Supervised is really where the algorithms require human assistance. And this is stuff like neural feedback, where you're almost teaching the algorithms, this is good, this is bad, don't do this, do more of this, and really giving it feedback so it can improve over time. Machine learning is not rules. So like regular expressions, thresholds, configuration, static kind of configuration or even standard deviation, like that isn't machine learning. And this is a big problem in our industry right now, in that there's a lot of vendors that have been doing the bottom bullet for many, many years. And it's like, hey, machine learning is the coolest thing. Let's pretend we do machine learning. And so this is why you're probably seeing every vendor on planet Earth claiming machine learning right now. And so this is what deployment automation looks like. We kind of like, as you mentioned, all of the steps for copying artifacts to servers, updating your configuration, whether it's in the cloud or on premise. Let's start with what verification looks like. So what is the data sets we're using or connecting to in order to get the data? And all of the tools you see here, we support out of the box. It takes about 30 seconds to hook in your webhooks to these tools. And then we can start to read the time series metrics following a deployment. And so here's an example. You've got a pipeline. Phase 1 of the canary was green. So you can see phase 1, New Relic's telling us that all the transactions in my application are good. You can see phase 2 of the canary deployment has failed. And if we take a look at that, you can see that 2 transactions in New Relic in the bottom right have turned red. So there's been 2 performance regressions that the machine learning has identified. And if we mouse over those, we can see why. Because one transaction has gone from 178 milliseconds to 251. So this is the instant feedback loop we're giving developers. Once you do deployment, we can go and take a look at all of the data in your tools, and the machine learning will build a model, and it will compare it to previous deployment or the previous canary phase to tell you what performance regressions have happened. And we do that using 2 algorithms for time series metrics. So first one is symbolic aggregate representation, or SAX. And if you look at the left-hand side, what we're doing is we're overlaying the test and the control data, and we're looking for the deviations between the values we see. So the first thing we do is we chunk up the data sets into time series chunks. So they can be like 10 seconds, 30 seconds, a minute. And then what we're doing is we're classifying the deviation. So if you look at the right-hand side, you can see there's 2 big deviations there, which are in yellow, and we're going to classify them either A, B, C, or D. And so if we see a lot of kind of the anomalies, we see that, like that typically is a high risk regression. If the anomalies are kind of within a certain range, like that's kind of cool. If you want to learn more about SAX, you can visit that website and you can go into horrific detail about how this algorithm works. But bottom line, what we're trying to do is we're trying to compare data for relatively the same time period, and understand for each time series metric, so for every transaction and every metric we analyze, whether you get these deviations in values over time. And that's what we call symbolic aggregate representation. So it's a fast way of quickly understanding deviations and for time ranges. Second one we use is hidden Markov models. And this is potentially where you get incomplete data sets. So where you don't get perfect alignment between the test and the control data, and you almost have to make probability guesses as to whether what you're seeing is normal or whether what you're seeing is abnormal. So to give you a simple example, if I get up in the morning, there's a 60% chance of rain, or there's a 40% chance of being sunny. Obviously, if you live in the UK, there's probably a 90% chance of rain, so bear with me on that. And if it's raining, what I can see is there's a 10% chance I'm going to go for a walk, there's a 40% chance I'm going to go shopping, and there's a 50% chance I'm going to clean the house. And so we can apply the same kind of concept to the data we see in Harness. So if we see certain patterns in data sets, so for example, if we see 2 big deviations and we keep seeing that with the next deployment, we can treat that as normal because we always see that particular deviation. So as an example, when you do a deployment, sometimes there'll be a warm-up period for the application where the caches might not be as kind of complete or full as you expect, and it might have to load information from a database, and so response times might be higher in the first 5 minutes of a deployment than the next 10 minutes. And so that's what allows us to do that. And also, hidden Markov models allow us to make assumptions when the data is incomplete. So you can see the testing of the control set there. You can see the control data, there's a piece missing. However, what we know is that, hey, if the before time series matches and the after the time series matches, we can probably guess that the control data we're seeing is normal. So there's no kind of, you wouldn't classify what you're seeing here as abnormal, even though it looks like there's a spike and the control data is missing. And so that's important as well, because in monitoring sources, sometimes it's inconsistent. There'll be pieces missing. And so like looking at the big picture as opposed to looking at just one spike allows you to reduce the false positives when you're trying to kind of flag regressions or anomalies. So we use hidden Markov models to kind of predict when data is incomplete. If we see matches, we can pretty much guess and say, you know what, that control data has piece of data missing. We can probably say it's spiked as well, because we can learn that over time and the frequency that this happens. The second verification source is application logs. So we talked about time series metrics and how we use machine learning on those to flag regressions and anomalies. Now what we're going to focus on is unstructured text data. And so here's an example. Same canary deployment in phase 2. And what we notice in Elastic is that there's 4 new errors that we've never seen before. And we flag those as red dots. And the position of the dots is relative to their natural language similarity. So what we're doing is we're trying to cluster together events that have textual similarity and space them out. So for example, this cluster you see on the right-hand side, that could be NullPointer exceptions. The dots you see on the left-hand side would be completely different than NullPointers because their textual similarity is very, very different. The gray dots you see are what we call baseline events. Those are events that the machine learning observes in every deployment. This is basically the noise and the crap that have been in your log files for years that no one's fixed or no one deems important. And what we do is we ignore those. You can still look at them, by the way. You can click on the dots and it will show you the stack trace of what we're baselining events as. But the red dots, you can see we're flagging as new and anomalous. And you can see where we've got the ignore button. You can, if need be, you can give feedback to the algorithms over time. So if you do deployment and we flag these 4 anomalies and you think they're kind of crap and false positives, you can train the algorithm and say, next time you see this particular event, ignore it there. And so it doesn't matter whether your log data is in Splunk or Sumo or Elastic or Logs or Scalar, like we can connect to that and we can apply our machine learning so you can quickly understand the anomalies from the usual crap you see in your log files. And it's, I mean, the first time you show this to developers, it's kind of like an aha moment because they get to see the actual exceptions that code introduced as opposed to the terabyte of log file that, how am I supposed to know which error relates to my code other than manually searching for the package or the API that I'm responsible for. And so what's cool again is you can see the stack traces. So almost an instant feedback loop. Hey, I just introduced these things. I can go and fix them now if I look at the stack trace. There's a few algorithms we use. Number one is entropy. Information entropy is basically to tell you how frequent something happens or occurs. So in terms of a log file, how frequent are the events we see in your log files? And so if you've got a string, as you see there, with lots of ones and kind of 1, 0, the actual character 0 has low entropy. It happens infrequently, and we believe that to be more important than the things we see all of the time. So you kind of think of your log files like all the class path exceptions you've acquired over years of developers not fixing them. Like that's noise, and that happens all the time. And so class path exceptions or class not found exceptions would have high entropy, and maybe a few null pointers that have been surfaced in a particular API that's been introduced would have low entropy. And so what we care about is really like the 80-20 rule. Like let's filter out the 80% of the noise that we typically see, and let's focus on the 20% that we think are important. And entropy is a way you can calculate that. We then use KMeans clustering. So what this does is it groups together events and exceptions based on their textual similarity. So if the structure of an event, if the textual similarity of its attributes is the same, we tend to group them together. So here's a simple example where imagine each of these dots is an event or an exception in your log files. The green might be null pointers, the blue might be array out of bounds exceptions, and the red might be a business exception. And so the reason they're not completely overlapping is because those exceptions can surface in different areas of your application. So especially in a microservices environment where you might have 50 or 100 microservices, a null pointer could be thrown in different microservices. It's still a null pointer exception, but it's in different locations. And so what we want to try and do is represent that in this nice kind of picture chart you see. Once we generate a value for their textual similarity, we then use Jaccard and Cosine distance calculations to basically position them relative to each other. So in terms of like, if I have 100 null pointer exceptions, I need to basically position them relative to their similarity, so that you don't just see one dot that represents 1,000 events. And this is how we space and position the events relative to each other. And again, you can go knock yourself out on Google, just search for Jaccard and Cosine, and you'll get unbelievable depth information on how we do this. And those are just more kind of algorithms we use. So a simple example, I have an application log file with 100 events, 10 of those are null pointers. Bottom line is those null pointers can be thrown in different services or different classes of the application. And so as a developer, you need to know that because not all null pointers are the same. You might have 9 of those null pointers that were thrown in class C, and that happens in every deployment, and it's happened for the last 5 years. Whereas you might have a null pointer that's thrown in class A, and that just happened today with today's deployment. And as a development team and as an organization, what you want to know about is what's the newest thing I've just introduced to the application. And that's kind of an example of why the natural language processing and the Jaccard and the KMeans clustering and the Jaccard, why we need that, so we can differentiate the different errors and regressions we see in log files. And so this is ultimately what we're trying to get to. If you want to simplify the chart that we provide customers, it's like, oh, look, I've got a bunch of null pointers. It's completely different to all the other things that I see that normally happen in my application. However, it's not perfect. And so as I alluded to earlier, it's never going to be 100% accurate or even 90%. However, if you can get machine learning to be 70, 80% accurate, it's a big, big win. And so sometimes there's there's sometimes attributes in the data we collect that throw off the algorithms. So things like customer account IDs or URLs or unique IP addresses where the importance of that data is skewing the importance of the event. And so what you see here is we flagged 2 anomalies that actually are not anomalies, because the reason they're flagged as anomalous is because they have text strings of account ID that are incredibly unique. And obviously, if we've never seen those unique attributes before, it has low entropy, and so we're going to flag them as important. However, any developer looking at this is going to be like, that's just an account ID. Like, that's so what? Like, that's not unique. That has no impact on the error or the exception. And so what we can do is we can apply neural nets on top of the KMeans clustering. So what neural nets do is they continuously look at all of the attributes, and they build a neural network of the attributes we're seeing. And then we use those to filter the results that we get from the control data. So before neural nets, we used to flag a lot of false positives. And again, the only way you could kind of filter those false positives out was if developers or humans could give it feedback, and you could say, hey, this is good, this is bad, ignore this, dismiss this, and that would train the model. Now what we can do is we can apply neural nets in real time so that we can consistently look at the new attributes we're viewing and filter and basically apply what we know and filter the results or filter the anomalies even further. So now you can see the accuracy of our algorithms is dramatically better. And so that's another way we're using to increase the accuracy. So the bottom line here is that unsupervised machine learning is cool, but it's more than one algorithm. It's not just this like, hey, I plug it in and it works. it's continuously tweaking, it's continuously looking at the different data sets and how the algorithms deliver these types of results. And so again, as a developer, like you've got to trust the information a product is showing you, otherwise you're just going to dismiss it. It's kind of how we've been conditioned, right? If you think about when an application breaks and you get 10,000 errors and exceptions and alerts, and PagerDuty is telling you like, hey, the application's broken, and you look at all the alerts that come in, you're like, meh, always happens. That's like, I'm not going to look at that because that happens every day. And you become conditioned because you don't trust the data. And so it's super important if we're allowing developers to deploy, that the data we give them back is as accurate as it can be. And so this is using neural nets is one way to do that. Right, there we go. Any questions?
Thanks a lot, Steve. Great presentation. We do have some questions that have come in. Let me read a few of them for you. You seem to be suggesting that when you're talking about the harness machine learning that it can be unsupervised, but it also takes some time for it to learn the basis of the organization's application, so it can kind of apply its algorithm secret sauce. How long does the ML take to kind of kick in and to start learning the application?
Yeah, so this is a common question we get, like how long does it take the machine learning to learn? And the short answer is it's instant. It's actually real time. It's done in memory. And the reason we do that is because if you're doing a Canary deployment, obviously the data set of Canary phase 1 needs to be compared with Canary phase 2. And so the time difference between the two is relatively short. Another reason we make it real time is because the past is not a good indicator of the future. And so you'll hear a lot of vendors say, hey, you need years of information to train the models and tell the machine learning what's normal and abnormal. Like that certainly worked 10 years ago when applications changed once or twice a year. But when applications change every day, historical data is kind of meaningless. And so what you want is you want your machine learning to be trained on information that's relatively new. Because if I go make a change in the application today and I make a change tomorrow, that's what I really care about is yesterday versus today, not what happened 6 months ago versus tomorrow or today. And so you typically need 2 or 3 deployments for the machine learning to get a good sense of what's normal and abnormal in the application. And if you want, I mean, you can apply supervision. You can totally do that. You can reinforce the algorithms. But most of our customers within 2 or 3 deployments, they're getting very, very good results with machine learning.
2 people have actually asked the same question, which is, can we get the slides for the presentation? I'll go ahead and take that. We definitely plan to send a recording of the presentation. And if you want the individual slides, absolutely just respond to the email with the recording. We'll be happy to send those to you separately. Here's one, Steve. The question is, the training data for hidden Markov models or other supervised learning, the question is it combined across the harness client customer base, or are those models trained in each product or application separately?
As of today, it's per customer account. Who knows for the future though?
Yeah. Well, I think also that allows them to focus on the individual performance of that application. It seems like if you were combined it with other applications, you might actually throw out the model, it seems to me.
That's actually correct, yes. And let me get into that. Every application is different, first and foremost. And so not just the application, but the log output, the log structures. And so like domains and markets and customers have very specific use cases, technologies, and configurations. There's definitely an end goal where you could do that. But right now it's all localized to the customer's account.
Next question here, Steve. Does the machine learning work with a time series database?
It does. I think I might have mentioned. So we have an API where you can basically point at either a webhook, a URL, or a REST API, and you can define the metrics that you want Harness to basically pull. So we kind of shipped that a few weeks back. So yeah, you can hook it up to any custom time series database.
And then the question is, and I think you kind of talked about this, because sometimes the machine learning is going to flag things which aren't really a problem. The question is, can you override the machine learning if you need to?
Yeah, so there's 2 ways. So I think I showed in the product, you can click ignore or dismiss. There's actually some static configuration if you absolutely want to. I personally wouldn't recommend that, because static configuration and thresholds, you kind of feel you need it because you want to make things incredibly accurate. But in doing that, you actually end up catching a lot of false positives. And so, as an example, in monitoring, a lot of customers might have said anything over 2 seconds, send me an alert, or flag that as an anomaly. The reality is that 95% of your transactions or user requests might actually execute in less than 2 seconds, but you might have some transactions, like a payment transaction, that takes 3 seconds or 5 seconds. And so putting a blanket configuration over an application, especially in today's world, is a bit crazy, because the app changes so frequently. And being able to model static configuration is just, it's a pain in the ass. Sorry to end on that note.
That was well stated, Steve. We do have a few more questions, but we're coming up on 50 minutes, so we'll go ahead and end it here. But we'll definitely follow up with the other questions we received, and as I mentioned before, as well as with recording of the entire presentation. I'd like to thank everyone for joining us today, and don't forget, you can always find out more about Harness at harness.io. Steve, thanks for joining us today.
Pleasure. Thank you all.